Symmetry can be a useful thing when we're drawing graphs, because if we know the symmetry of a graph, then effectively we only have to draw half of it, because then we can just reflect it or whatever we have to do. So odd functions. Remind you the definition for an odd function. Function negative x is equal to the negative function x, and as I was saying yesterday, I could rearrange that and write that as function x equals negative function negative x, which was our condition for the rotation 180 degrees. So hence that means all odd functions will have point symmetry about the origin, which also means another important fact. Every odd function is either discontinuous at x equals 0 or goes through the origin. Has to do one of the two. If you spin it 180 degrees, it looks the same. So our hyperbola is a classic one there. It's discontinuous at x equals 0, you will notice. The cubic is also an odd function. That one goes through 0, 0. So rotate it 180 degrees, you get the same picture. So x cubed, 1 on x, x to the 7 minus x to the 5, whatever that looks like, that would be an odd function. And minus 3x to the 9 plus 2x to the 7, that would be an odd function. In fact, if all the powers are odd, it must end up being an odd function. Now that's not enough to prove it's odd. If they say prove it's odd, you can't just say, oh look, all the powers are odd. If you have to prove it, so let's prove x cubed plus x to the 7 is indeed an odd function, we have to show it satisfies that condition. So let's say, there's the original function, x cubed plus x to the 7. Function negative x, everywhere I see an x, substitute in negative x. If I cube a negative number, it'll be negative. If I raise a negative number to the power of 7, it will be negative. So we get minus x cubed minus x to the 7, which I can factorise, and we end up with minus function x. So it satisfies the condition, yes, that is an odd function. So when it comes to sketching that one, we know rotational symmetry, we've got an idea of what we're looking for. Even functions are the other important type when it comes to symmetry. They're the ones where function negative x equals function x. So it has line symmetry in the y-axis. The parabola is a perfect example. Some examples. So there's our parabola. X squared plus 4 would be minus 3x to the power of 6 plus 2x to the power of 4 minus 27x squared would be, in fact, all the powers are even. And for the sake of that definition, all the powers are even, we consider 0 to be an even number. So constants would be like x to the power of 0. So that's okay. Let's prove x squared plus 4 is indeed an even function. So again, we've got to prove it satisfies the condition. The original function is x squared plus 4. Function negative x, well, square a negative number, we get a positive number. We end up with x squared plus 4, which is function x. So yes, that is an even function. And that'll do us for today.